Today, we're going to look under the hood of AI image generation. We're talking about a really critical concept, guided diffusion. Think of it as the steering wheel that lets us actually control these incredibly powerful creative engines. So, have you ever wondered how an AI takes a completely wild idea, like a corgi riding a bike in Times Square, and somehow produces a detailed, believable picture that actually matches the text? Yeah, that's the big question we're going to answer. To get there, though, we first have to understand what these models do by default. What happens when there's no one at the steering wheel? What does a standard diffusion model actually do on its own? Okay, imagine a sculptor who starts with a big block of marble, but they're completely blindfolded. They just start chipping away, following all their training and instincts, and they end up creating a totally stunning statue. The catch? They had absolutely no idea what they were making until it was done. That, right there, is a standard diffusion model. It turns a screen full of random noise into something beautiful. But what it creates is always a complete surprise. And this brings us to the most important point. How do we take that blindfold off? How do we give the sculptor specific instructions? Answering this is the key to understanding why modern AI image generators are so incredibly powerful and controllable. This is the exact problem that guidance was created to solve. So how do we actually give it those instructions? Well, it turns out the AI has a few key methods in its toolkit for steering this whole creative process. First, you can guide by class. This is basically telling the model, hey, I want an Arctic fox, picking from a list of categories it already knows. Second, you can guide it with specific measurements, which is perfect for jobs like adding color to an old black and white photo. And third, the one we all know and love, is guiding it with a super detailed text prompt. Now, while all three are really important, the real breakthrough in getting control came from an early attempt at that first method. So let's look at the first big attempt to control these models. It's a method called classifier guidance. And, it was a really clever idea, but as you're about to see, it came with some serious drawbacks. Let's go back to our blindfolded sculptor. With classifier guidance, it's like we hire an art critic to stand right next to them, and this critic is just yelling directions at every single step. No, make it more fox-like, less like a cat, the ears need to be sharper. So what's happening on a technical level? Well, this critic is a totally separate AI model, an image classifier that's been trained to recognize things. At every single step of the denoising process, it looks at the half-finished image and gives feedback. This feedback is called a gradient, which is really just a fancy way of saying it gives a little nudge, a little more of this, a little less of that. But here's the huge problem. For years, we've known that the gradients you get from these classifiers can be, well, pretty horrible. They're super easy to fool with tiny changes, which is what's known as an adversarial attack. So the critic's directions often sound more like pure static than useful advice, pushing the model in really weird ways and creating strange, unnatural glitches in the final picture. This weakness, though, actually led researchers to a much more elegant and way more powerful solution. Instead of hiring this noisy external critic, they asked, what if the guidance could come from inside the model itself? And that is the big leap forward. We're moving away from a separate, unreliable critic to a system where the generative model itself understands the instructions. This is called classifier-free guidance, and trust me, it's the technique that powers basically every modern text-to-image model you've ever used. The core idea here is so simple but so powerful. During training, the diffusion model basically learns to do two jobs at once. Sometimes it learns how to denoise an image with no instructions at all, just like our blindfolded sculptor. But other times, it's given a condition, like the word husky, and it learns how to denoise an image to match that specific label. It's one model that can operate in two different modes. And here's the really clever part. At every step, the model calculates two possible directions. First, the path it would take with no guidance, and second, the path it would take if it were guided by the prompt husky. The guidance signal is literally just the difference between those two paths. That difference is the pure huskiness direction. And then we can amplify that signal with a scaling factor, which we'll call S, to control exactly how strongly the model follows the prompt. So as we crank up the value of this S factor, the guidance gets way stronger. If S is set to 1, you get a result that's, subtly guided. But as you push it higher, to 3, and then all the way up to 8, the image becomes much more sharply defined, much more obviously a husky. This S value is a key knob that artists and engineers use to fine-tune the final output. Okay, so we've got the core technique down.
Now let's pull back the curtain and see how a state-of-the-art model like Google's Imagen actually uses classifier-free guidance to go from a simple sentence to a giant, high-resolution photograph.
Turns out it's a whole multi-stage process. First, a language model, something like Clip, converts your text prompt into a meaningful string of numbers. Then, a diffusion model uses our classifier-free guidance to generate a teeny tiny 64 by 64 pixel image that just captures the essence of the prompt. And finally, a whole cascade of other guided diffusion models takes that tiny image and upscales it again and again, adding more detail until you have your final high-res picture. So how do researchers even know if all this is working? Well, they mainly use two key scores. There's the FID score, which measures the overall quality and realism of the images. For that, a lower score is better. And then there's the clip score, which measures how well the final image actually matches the text prompt you gave it. For that one, a higher score is better.
And here's one last fascinating little detail. When you crank that guidance strength S really high, the pixel values in the image can get so extreme that they go totally out of bounds. You get these blown out, super bright highlights or crushed all black shadows. To fix this, models like Imagen use a clever trick called dynamic thresholding, which basically just reins in those extreme values at each step, keeping the final image looking clean and balanced.
This technology is moving at an absolutely breathtaking pace. The principles of guided diffusion aren't just for still images anymore. They're now being applied to the much, much harder problem of generating video. I mean, just look at the timeline from early 2024. In the span of just a few weeks, we had Google, Stability AI, OpenAI with its incredible SOAR model, and then Midjourney all announce these massive leaps in text video generation. The race is well and truly on. This really shows that the core ideas we've talked about, starting with noise and guiding it toward a specific goal, are now being applied to create not just pictures, but also video, audio, and even 3D shapes. And right now, video generation is, without a doubt, the hottest area of development. And all of this leaves us with one final provocative thought. If the leap from high-quality images to stunningly realistic video can happen this quickly in just a matter of months, what breakthroughs are just around the corner? It's a question that is as exciting as it is completely impossible to answer.